Welcome back. This course is designed to understand and use two technologies put together, Spring Cloud Streams and Kafka Streams. In this video, I'll give you a formal introduction to the Spring Cloud Streams. Let's begin. Spring Framework always aspired to simplify enterprise Java development. They offered the Spring Boot framework to simplify creating Java-based microservices. Similarly, the Spring Integration Framework was designed to provide a solution for simplified application integration. However, some modern enterprise applications started to implement distributed event-driven streaming architecture. These applications showed two common traits. They run in a cloud platform and follow a microservice architecture. They continuously operate on a stream of events or messages. Spring Integration Framework already offered a similar solution for enterprise integration patterns. In this pattern, one application publishes a message to a common message channel. Other applications can read the message from the channel at a later time. In all this, the applications must agree on a shared channel and the format of the message, and the communication remains asynchronous. Spring realized that this framework could be extended and simplified further to support the modern demand for event-driven streaming architecture. As a result, Spring came up with a new framework, Spring Cloud Streams. Spring Cloud Stream is a new framework that combines the power of two Spring frameworks, Spring Boot and Spring Integrations. So, the Spring Cloud Stream builds upon Spring Boot to create standalone production-grade microservice applications and uses Spring Integration to provide connectivity to message brokers. As a result, Spring Cloud Stream turns out to be a framework for building event-driven stream processing microservices. Great, that's all for the background. Now let's try to understand the Spring Cloud Stream architecture. How does it work? A Spring Cloud Stream application is a message-driven microservice application, right? All we do in a Spring Cloud Stream application is to consume message events, process it to take necessary business actions, and produce events for other microservices. And a typical Spring Cloud Stream application is internally architectured like this. So we have the main application code for processing message events received through one or more input channels. The core of your application implements all the business logic and takes the necessary business actions. Finally, if needed, we can produce message events to one or more output channels. And that's where most of the developer focus lies. An application developer is focused on processing message events, implementing necessary business actions, and producing new messages. Rest all is taken care of by the framework. Spring Cloud Stream allows you to create and configure input-output message channels using simple and straightforward configurations. These channel configurations are also known as Spring Cloud Stream bindings. And these bindings are picked up by the binder to implement the input-output channel and communicate with the external messaging system. So the binder is a third-party Spring component responsible for providing integration with the external messaging system. As of date, we have a bunch of open source and third-party binders. Here is an indicative list. The binder is responsible for the connectivity and routing of messages from the respective messaging systems. They are also responsible for data type conversions and few other things. But the most essential feature of the binder is this. They will collect the incoming message events from the messaging system, do the necessary data type conversions, call the user code, and pass each message to you for processing. Similarly, they'll take up your outgoing message events, do the necessary data type conversion, and send the message to the underlying messaging system. The point is straight. Most of the headache of interacting with the messaging system is taken care of by the binder. However, you will also need to configure the binders according to your requirements. So, in short, a Spring Cloud Stream developer is responsible for the following things. Configure input-output channel bindings. Configure the binder. And finally, implementing the business logic. Many of the channel binding configurations and the binder configurations are defined in your application YAML. However, several things are configured using Spring Cloud Stream annotations. And if you are familiar with the Spring Boot programming, you should be already familiar with the notion of Spring annotations and Spring configurations, right? Great. Now let me open the earlier example and correlate a few things that we learned in this lecture. Here is the example that we created in the previous lecture. Let me open the application YAML. Your application YAML is the first place where we configure the channel bindings and the binder. You can clearly see two configurations. The first one is the channel bindings and the second one is the binder configuration. I created only one input channel for this application and named it input channel 1. However, in the coming examples, we will be creating multiple channels. Some of those will be input channels and others will be output channels. The binders are responsible for communicating from the messaging system. So we configured it with the connection details such as hostname and port. Similarly, the binder also needs to perform data type conversion. So we configured it with the message key and value types. The next and the most typical step is to define an interface for your input-output channel. That's what I did here in the Kafka listener binding interface. I created only one channel. So I defined one method here. This method configures two critical things. The first one is to configure the input channel 1 as an input channel. When I configured it in the YAML file, I didn't specify if I want to use this channel as input or for output. That's what we do here. The @input annotation makes this channel as an input channel. The second critical configuration is to set the expected data type of the message stream. And I'm setting it here as a K stream of string key and a string value. We will learn more about the K stream in the coming lectures. But K stream is a streaming data type offered by Kafka Streams API. Great. So we learned two places to configure the bindings and the binder. The next thing is to implement business logic. But where do we do that? That's what we do in the service class. So here is my service class. I enabled binding for this class using my Kafka listener binding interface. Now Spring knows that we want to communicate with the messaging system for the input-output channels defined in this interface. As of now, I configured only one input channel. So the framework will start reading incoming messages from the configured channel. Now let's come back to the service class. So enable binding will trigger the reading of messages. But then we want to process those messages. So we defined a process method and configure it to become a stream listener. So we tell that we want this message to listen to the input channel 1. Now the framework will call this method and pass the input stream. So we are not writing any code for connecting to the Kafka messaging system. We do not need to read messages from the Kafka cluster. All is done by the framework. The framework will read the message from the input channel 1, invoke this function and pass the message here in this function. Now you can do whatever you want to do with the incoming message. I just want to put it in the log. But you will be implementing business logic here, right? Great. That's all about the Spring Cloud Stream framework. And I hope you understand the high-level structure of a typical stream processing application. The Spring Cloud Stream supports a bunch of messaging system. I already showed you some supported binders. However, this course is about Kafka. So, let me talk a little about the Kafka binders. Spring Cloud Stream supports two Kafka binders. The first one is the plain Kafka binder that internally implements Kafka Producer and Consumer Client APIs. The second one implements the Kafka Streams API. This course is focused on the Kafka Streams binder implementation. Kafka Streams is an extension of the Producer Consumer Client APIs and it offers you out-of-the-box stream processing capabilities that are not offered by the Kafka Client APIs. So, this course is focused on the Kafka Streams binder. Make sense? Great. That's all for this video. See you again in the next video. Keep learning and keep growing.